Hoover Dam is definitely a miracle in the history of architecture. More than 100 workers even sacrificed their lives to build it. Therefore, Hoover Dam is also called the crystallization of blood and concrete. Hoover Dam was built in a narrow canyon. This saves material by taking advantage of the mountains on both sides. If the dam is designed as an ordinary concrete wall, then it will inevitably collapse under the impact of huge water pressure. The talented designer chose to add curvature to the concrete wall and greatly increase the thickness of the bottom, because the deeper the place, the greater the water pressure. And this design makes the shear stress in each cross-section almost the same. This is the basis for the Hoover Dam to stand for hundreds of years. But the construction of the dam is not that easy. First of all, the rocks on both sides have become very fragile after weathering. So they just blew up this part of the rock directly, then clean up these gravels. This is a lot more convenient. Now come to the side of the mountain and dig out 2 arched grooves. At this time, the dam will be more firmly embedded in the groove. Can concrete be poured directly after the wooden frame is erected? The answer is definitely no, because cement continuously releases heat when it comes into contact with water. The internal temperature of the concrete is much higher than the external temperature. This creates cracks on the concrete surface. To solve this problem, the designer divided the dam into many small pieces. Concrete is then poured into these molds one by one. There are pipes in the mold that carry cooling water to cool the concrete. I have to admit that the designer is really a genius. The Buddha Dam not only prevents floods but also generates electricity. First, put several water inlet towers upstream. Its function is to regulate water flow. As water is transported through pipes to the turbine, the potential energy of water is converted into mechanical energy to drive the turbine to rotate. The water turbine drives the generator to generate electricity. Finally, after boosting, it can be connected to the power grid. The water from the turbine is released through the downstream outlet.